All right, let's keep on keeping on. Guess what we get to do now? Trig, yo. I know how much you guys like trig, so let's do some now. Okay, here we are. This is, again, implicit differentiation. We have x's and y's. But just because it's implicit differentiation doesn't mean we still continue to use everything we know about derivatives. So we're going to kind of put it all together. Look at what's happening right here on this left side. I have sine, which is an outside function, and I've got some inside business. So if I have an outside with an inside, what are we doing? Chain. Ooh, look at this coming back, making a comeback, yo. If I have the x and y, what do you see about these two? Product. Good. So whenever we do the chain, we take the derivative of the outside, but when we go to take the derivative of that inside because of chain rule, then we get the amazing opportunity to use product rule. Okay, well, without further ado, let's rock the socks off of this. Okay, so the derivative of the left here, the derivative of sine is cosine, keeping the guts. Then I multiply by the derivative of the inside. And when you multiply by the derivative of the inside, we're doing the product rule, right? So the derivative of the first is just a 1 times the second, which will give me a y, plus the first times the derivative of the second. And this is with respect to x, right? So then that's where that dy dx is going to come into play here. Equals, then the derivative of the other side, x here is just going to, or x squared here is just going to give me a 2x plus, and then y again will be that dy dx. Because it's the derivative of y with respect to x. All right. Now, my ultimate goal is to get this dy dx by itself, right? Well, I can't mess with that while it's inside these parentheses. So I'm going to need to take this cosine here of xy and distribute it. So I can get that dy dx out of those parentheses. So I have y cosine here of xy plus x dy dx cosine of xy is equal to this 2x plus dy dx. Now I have a dy dx term and a dy dx term, so I'm going to get those together. It makes me feel better to put them on the left-hand side, but you can kind of do whatever you want. But I like having it on the left-hand side, so I'm going to subtract this y cosine xy minus y cosine xy. And then I'm going to also subtract this minus dy dx minus dy dx. Oops, that's a d there. So this cosine, here is going to go over to the right. Your dy dx is going to go over to the left. Now, these are not like terms. You cannot put those together. These are not like terms. You cannot put those together. So basically, all you're doing is just rearranging is what's going on. And I want to get those dy dx's on the left because I need to be able to factor that out. Okay, so here I have x dy dx cosine here of xy minus dy dx is equal to a 2x minus y cosine of xy. And then I have this dy dx in common, so I can factor that out. So if I factor out a dy dx, I'm left with x cosine xy minus 1. You have to have that 1. That is still a term, right? If I divide by the same thing on the top and the bottom, I still have a 1. You divide that dy dx out, you still have that 1. You can't forget it. It's important. So minus y here, cosine xy. Now again, just rearranging. My goal is to get that dy dx by itself. So it is now multiplied by what's in these parentheses. So I'm going to divide by this x cosine x. Oh, that's a y, contrary to what it may look like. Minus 1 divided by x cosine here of xy minus 1. And I have my dy dx now equals 2x minus y cosine xy over x cosine xy minus 1. Now, is there anything I can do to simplify this? No, there's not. There's not anything I can do to simplify this. And here's the reason why. Anything touching a plus or a minus. So there's no way to take these out, this cosine xy, because of this minus sign right here and this minus sign right here. These are bound together. The only way you can simplify is with a multiplication. So anything touching a plus or minus, anything touching a plus or minus is off limits. You cannot mess with it. If it's touching a plus or minus, it's off limits because that's part of that term and you can't mess with that because it affects the integrity of the problem. All right? Okay, so moral of this story. Look at what just happened. Yeah, this is a fairly long problem, but look what happened. This was my original problem. We wanted to find dy dx. We did chain rule, product rule, derivatives. Did we do any more calculus for the rest of this problem? No, we did not, right? This is all algebra. Algebra is our friend, yo. We love algebra because that's what the majority of calculus is. We did a little bit of calculus in this one step right here. Other than that, we just algebra'd this out. Got the dy dx's together, factored them out, and then divided. Everything else was just algebra. All right. Great job. Let's keep the momentum going with this amazing math.